So this question is about displacements and bearings for vectors. So always with a question like this, I would start drawing it out. So if we look at part A, we've got a bearing. So obviously bearings always measured from due north. So we've got a bearing of 40 degrees with a magnitude of 2.5 kilometers. And then from there, again measuring from due north, we've got a bearing of 120 degrees and a magnitude of 6.9. So there was my first vector. There's my second vector. So the resultant vector is going to be that one there, drawn in red. Okay, so we've clearly got a triangle. It's not a right angle triangle, so we're thinking about sine rule or cosine rule. So the first thing I want is the magnitude of the vector. So that's going to be the length of that side there. So if I start looking sort of around here and here, if I can get that interior angle of the triangle, I'm going to be able to use cosine rule. Well, I know that that's 120 degrees. And if I look here, these two lines are parallel because they're both going due north. So I also know that that angle plus that angle adds up to 180. So I know that that's 140. I know that that's 120. So if they add up to 260, that angle must be 100, because obviously those two angles add up to 360. So then I can go into cosine rule. So a squared is 2.5 squared plus 6.9 squared minus 2 times 2.5 times 6.9 times cos 100. So let's quickly type that into the calculator. So 2.5 squared plus 6.9 squared minus 2 times 2.5 times 6.9 times cos 100. So a squared, well, that seems a bit big, doesn't it? I've not put 69 instead of 6.9. So let's just quickly go back and change that. Okay, yeah, that seems more reasonable. So a squared is 59.85. So a is 7.74. Okay, so I've got the magnitude of the vector. So now I need to find the direction. So I'm after that angle there is the bearing. So I know that that's 40 degrees. So if I can get that interior angle of the triangle, then I'm obviously going to be able to add those together and have it as a bearing. And I think I should be able to do that because I've got 100 degrees and 7.74, so that's one opposite pair of sides and angles. And then I've got 6.9, if I call that angle theta. So I can use sine rule and say that sine 100 over 7.74 will equal the same as sine theta, this angle I'm trying to find, over 6.9. So let's quickly work that out. So sine 100, sine 100 over 7.74. Then if I multiply up by the 6.9, I get that sine theta is 0.8. Let's go to four significant figures, 0.8779. If I inverse sine that, I get theta is 61.4 degrees. Okay, so let's think about how I want to give these final answers. So looking back at the question, it looks to me as though they've given the displacement to the nearest tenth of a kilometre. So that's the level of accuracy I will give my displacement to. So 7.74 would round to 7.7 kilometres. And then for the bearings, they've gone to the nearest degree. So don't forget that the 61.6 is just that interior angle of the triangle there. So the total bearing, so I'm going to say that that's 61 degrees. So the total bearing is going to be 61 plus 40, so 101 degrees.